Java is a high-level, class-based, object-oriented programming language. It's a general-purpose programming language designed to let app developers write once, run anywhere. Today, we're diving into the world of Java, so let's get started. Welcome to the Ladybug Podcast. I'm Kelly.
I'm Sydney.
I'm Allie.
And I'm Emma, and we're debugging the tech industry. This episode is supported by Compiler, an original podcast from Red Hat discussing tech topics big, small, and strange. Compiler is brought to you by the creators of Command Line Heroes and is hosted by Angela Andrews and Brent Simino. It's no secret that technology can be complicated and frankly a little intimidating. Compiler unravels industry topics, trends, and the things you've always wanted to know about tech by interviewing the people who know it best. I checked out the Should Managers Code episode where the hosts discussed the 80-20 rule. 80% of a manager's time is typically devoted to managing, while 20% is devoted to coding and problem solving. They discuss how it can be hard to close the door on your identity as a creator, something many new managers struggle with. The hosts also discuss how you can keep your skills sharp when most of your time is spent managing. I thoroughly enjoyed this episode, and I know you will too. Listen to Compiler on Apple Podcasts or anywhere you listen to podcasts. We'll also include a link in the show notes, and many thanks to Compiler for their support. So let's start off by talking about all of our experiences working with Java. I'm going to throw it to Kelly first because I know her answer and it'll be a short one.
It is a short one. I took AP Computer Science in high school, and that was Java-based, and I needed a tutor just to pass the class, and I did not take the AP test. That was the extent of my Java experience. Sydney, what about you?
Fabulous.
That's awesome. Okay, so at my previous job, I had done a lot of work in Java, specifically Java 8. So what was going on with it? That was a lot of legacy code that we were trying to spruce up for like a really big front-facing application with like high traffic users and everything. And that was fun because a lot of shit broke majority of the time. And so that kind of didn't really give us some leeway to like actually improve the code to do other things. So that was fun. It wasn't the most pleasant experience that I've had with Java. So I'm a tad bit traumatized. So yeah.
That my experience is also traumatic. I studied computer science in school and we did all of our classes using Java. I hated it. I think because my first introduction to Java was with a professor that, to be honest, was just degrading.
Okay.
Like he would tell us that like basically none of us were going to pass the exam. And he offered students like, you can take a 50%, which is a failing grade, instead of taking the exam because it's probably going to be higher than what you'll get anyway, even though it's an open notes, open internet test. Like it was just very much, I didn't learn what I needed to learn to succeed with it. So I just hated it.
Terrible professor.
But we did build some fun things. Yeah, it was. I built a tic-tac-toe game, but it was Star Wars themed. So like the different like circles where you would like fill in X or O's, they were like Death Stars, and then you had like different characters, and anytime that you placed a character it would make like a lightsaber sound, so that was pretty cool. I also had to, our like capstone project was to create the board game Ticket to Ride, and I will never do that again. I will never even play the board game again because it was that bad.
That's so sad. It's such a fun game.
What is Ticket to Ride? I have no clue what that is.
It's like a strategy game.
Yeah, it's a board game where you're basically connecting two cities and you're collecting cards, and you have to basically
build railroads.
You're creating a railroad from like place to place to place to place.
Oh, I've seen this before. Okay, I didn't know it was called Ticket to Ride. Okay, I got you. I know where you're talking about now.
It is actually pretty fun, but it was a lot to code, especially because all of the images, there were like hundreds of images that we had to import. It was just a mess.
God.
And we were using Eclipse, which is a terrible IDE for me. Like it was too robust. I didn't love it. And then at my first job at IBM, we would write tests in Java. So I did have some professional experience with it, but like, yeah, I hated it. So cool. That's our experience working with Java. So glad we're doing an episode on it. But let's talk a little bit about the history, because I actually found the history to be pretty cool. So Java was developed by James Gosling primarily at Sun Microsystems, which has since been acquired by Oracle. It was released in 1995 as a core component of Sun Microsystems' Java platform. It was originally designed for interactive television, but was too advanced for digital cable TV industry at the time. I did not know that.
That's
How
fascinating.
Cool.
That's
right.
Fascinating.
Okay.
I loved it. It was just too complex and didn't work. That says a lot. So Java was originally called Oak after an oak tree that stood outside Gosling's office. Later, they changed that name to Green, and finally it was renamed Java from Java coffee, which is a type of coffee from Indonesia. So that's interesting too. And then we all know how JavaScript got its name, even though they're not related, right? Just kind of like piggybacked off the notoriety. But
right.
I wish they explained why they changed the name so many times. Like, and why did they change it to Green? I don't know.
Why
if they were
Green?
trying to be
Yeah, exactly.
Yeah. I don't know. Naming things is hard. We all know this. Java 1.0 was released in 1996 when I was a mere toddler. It promised write once, run anywhere functionality. So that provided no-cost runtimes on popular platforms. And it allowed for network and file access restrictions. And major web browsers soon incorporated the ability to run Java applets, which are small Java apps, within web pages. So Java quickly became popular. Interestingly, I didn't know this. In 1997, Sun Microsystems approached the ISO/IEC JTC1. I don't know why we have so many acronyms.
That.
Yes, fabulous. I don't know what any of it stands for, so we're just going to roll with it. But they approached the standards. I assume it's like a standards committee, like the equivalent of like ECMA for JavaScript. So they approached them in 1997, and later they also approached the ECMA International to formalize Java. But it actually withdrew from the process, and today it remains a de facto standard and is controlled through the Java community process. I didn't know that.
Fascinating. Okay.
Kind of strange. I'm curious why it withdrew. Like, did it just have enough community support that didn't need to abide by the standards? I don't know.
I wouldn't be surprised by that.
Restrictions and yeah.
That's interesting.
That was when?
In 1997.
So only a year after 1.0 was released.
Mm-hmm.
Right.
That's baffling.
Right.
Huh.
But so as of March 2021, the latest version is Java 16. So that's where we're at today. There were 5 goals of Java. The first is it has to be simple, object-oriented, and familiar, which makes me giggle because simple, it is not. Let me tell you. It is a very verbose language, and that's part of the reason it turns me off.
I was gonna say one of these goals better be to make my life a living hell, because that was my experience with it.
I think that if we're very analytical and losing that kind of creative side of what like you're going to be doing in terms of like web development, then Java definitely does the job. You kind of lose that creativity and you're more like analytical with most things as you're working with it. So, I mean, maybe it gets a lot simpler as you kind of like go forward with some of the newer versions of the language, but I have not experienced that just yet. So
correct. Yes. I find this, and we'll talk about what strongly typed is later on, but it's a strongly typed verbose language. So yeah, I think they failed, in my opinion, at this first goal. But it is definitely object oriented. I don't know what the hell familiar means. Like,
people who are like a really big fan of Java are going to be listening to this episode and be like, wow, they really hate Java.
Emma's like throwing shots, just boom, 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 boom.
So here's the thing. Like, and this goes for anything that you're learning in life. If you've got a bad experience with a terrible teacher, you're not going to enjoy it. I'm sorry.
Exactly.
And like, that has just totally tarnished my viewpoint on it. And that's also because it really hindered my ability to learn programming concepts foundationally.
Yes, I agree. That was exactly where I was feeling when it comes to my abilities for a really long time. Like, it made me feel like I was not a programmer at all. Like, I couldn't do JavaScript, even though I was formally trained in JavaScript, because I couldn't figure out what was going on with Java over the course of like throwing like water on fires and then like whoa, they turned out to be grease fires, so we made it even worse, all that fun stuff. So I totally understand where you're coming from.
It was a humbling experience trying to learn.
100%, yes.
It's just like, I didn't understand concepts like inheritance and overriding and overloading and encapsulation. I didn't understand these concepts until I was like a couple years into my JavaScript career as a professional web developer, because even though JavaScript is not an object-oriented programming language, it had like class syntax, syntactical sugar, and that helped me learn. But when I was coding in Java, I literally had no idea what a constructor was because I was never taught it. I was just thrown into it and expected to like swim. Yeah. So that if people listening are like annoyed that I had a bad experience, that's just the reality of it. And
we're not the only ones that have had bad experiences with it. Yeah. So please understand that, I am so gracious for the community of like tech people that we do know that, would help us if we needed any type of advice or kind of going on with Java specifically as a language. But if you guys have looked at any of these like documentations kind of lately, it's definitely not as modern, not as, more kind of image-based, not as much like, it's more analytical. Right. It's making you like think a little bit more when it comes to like the technical kind of processes of it, which is fine. But, just it's for different strokes, different learning preferences for people. And it's a lot. It's definitely a lot.
Well, and like if you compare the syntax of it to another language like Python, it is much more verbose. I'm going to say verbose a lot probably because like take for example, public static void main string args, like that is a huge ass like signature. Okay. And you need it. Right. But like, it's so confusing for beginners to come in and see this and not have it properly explained to me. Like, what does all of this do? So my personal opinion is this was not a great first programming language for me. I think Python would have been a much better introduction to programming language than Java. And that's just my personal opinion. I think Java is great for many reasons. It's great for enterprise applications. It's not so easy for beginners.
Yeah, I completely agree with you.
The 4 other goals of Java are it must be robust and secure, which I would say it is.
Yes,
it must be architecture neutral and portable. It must execute with high performance, and it must be interpreted, threaded, and dynamic. And we'll talk about what those things mean in just a second. One thing that Java is known for being is an object-oriented programming language, which I mentioned in the intro. And you'll see this abbreviated as OOP. That's how we called it in school.
And OOP.
So every single time I read object-oriented, that's what I see. That's what's in my head.
So an object-oriented programming language is a paradigm based on the concept of objects, which can contain data in the form of fields, which are known as attributes and properties, and code in the form of procedures, which we call methods. Objects own methods and can access and modify the data fields of itself. And we'll give you some examples conceptually of how this works in just a little bit. But the most popular object-oriented programming languages are class-based, meaning that the objects are instances of classes which determine their types. So, for example, let's say we've got a class of animal. We can have different instances of this, and we'll talk about inheritance and all that. But a dog is an animal, so is a relationship, and this class can have a type of animal and a sound it makes and a name. And every time you instantiate or extend a new class of animal, it comes with these properties. So that's kind of the basis of it. And this was really hard for me to wrap my head around in terms of building really data focused apps that weren't necessarily you really have to change your paradigm of thinking when you really have to think in terms of objects. And that can be really difficult when you're building apps that you don't necessarily see in terms of objects.
Yeah, I can see that.
So let's talk about what it means to be a threaded language. JavaScript is a single threaded language, but Java is a multi-threaded language. So what is a thread? A thread of execution is the smallest sequence of programmed instructions that can be managed independently by a scheduler. And this scheduler is part of the operating system. So multiple threads can be executed concurrently, sharing resources such as memory. And Java is multi-threaded, meaning it can perform tasks simultaneously. I think like maybe an analogy would be like if you're in a restaurant, you've got like the chef is cooking, meals, the waiters are out taking orders. It's like you can have multiple things going on at once.
Right. That makes sense.
Right. But a waiter, I think like the way I think of like asynchronous programming with JavaScript is like a waiter is like technically single threaded, for example. So he or she or they will come to your table, they will take your order, they will walk it back to the kitchen. They can't be doing like taking multiple table orders at once and all of that. So that's just my off the cuff analogy there, but I think it kind of helps visualize what we're talking about.
Yeah, that was a good one.
So what does it mean to be an interpreted language? Would either one of you like to maybe explain what that is?
Yeah, definitely. So an interpreted language is meaning that its bytecode is translated on the fly to the native machine instructions and it's not stored anywhere from what I understand. And so the development process is actually more rapid. Like it's going to be a lot faster as a result when it comes to executing whatever process that you're kind of going through. So what can we use as an analogy for that, actually?
I have no idea because in all honesty, I don't fully understand what this means. And I think that's fine. Like, again, this just goes to show you don't need to know everything in life, especially because I don't work with Java anymore. So like, I can't give you an analogy.
Oh my gosh.
Okay. I don't know if this is going to be helpful or not, but I just Googled it and this was somebody's analogy. Think of, an interpreter versus a compiler translating the program into a machine code and then executing it. Think of the two like this analogy. Your code is a letter written in Spanish. Your computer is a Chinese speaker. The compiler and the interpreter are linguists or language translators. Both the compiler and the interpreter in the end do the same thing. They want to translate one language into another, but each have a different method of doing so. The compiler's method is to take the Spanish letter, translate it into the new letter in Chinese, and then mail the new letter in full to the computer's house, the Chinese speaker's house.
Oh,
the interpreter's method is to take the Spanish letter, go to the computer's house, and then just read the letter out to the computer in Chinese.
Nice.
That's really helpful.
Yeah.
Whoever wrote that gets a medal. We're going to link that in the show notes. So Kelly, if you could add that would be fabulous. Fabulous. So, and I think it's a given that, or isn't it an argument like JavaScript is a compiled language?
Yeah.
That was like a common argument of like some people saying it's not, some people saying it is. We're not here to talk about JavaScript. I like to relate back to it because that's what we primarily talk about is web development. But that was a fabulous analogy.
That was really helpful. Yeah.
Very much so. Why don't we kind of dig a little bit deeper and start talking about some of the terminology that you will commonly hear when it comes to Java? Let's go for that. The biggest thing I think that you'll be hearing as you kind of go along choosing Java as a programming language is the concept of an object, which has, you can think about it, I guess. I've normally thought about it as a space where you're able to give whatever this physical object is in this analogy, personality, different types of properties, different things that you're going to actually be doing with it, what it looks like potentially. So objects have states as well as behaviors. And so going back to Emma's example, a dog has states like color. It has a state that's a name. It has a breed. It has behaviors such as, okay, it wags its tail. It barks. It likes to eat. It likes to, I don't know, like
lick things and make it all gross.
I was going to say lick its butt, but so there's that.
Glad we're on the same page.
Good. And an object is going to be an instance of the class as a whole. So you're going to be keeping majority of your states, its personality, different things that you're going to be describing for that object. It's going to be coming from the instance of the class that you're referring to.
So yeah, so like I mentioned earlier, like a class of animal, but let's say we've got a class of dog and it has all the properties and methods that Sydney was just saying. It has a color, name, breed, and then the methods are like wag tail, bark, eat. Every time you instantiate a new object, it's going to have its own name, color, breed, and you'll pass these things into the constructor, these properties in, and every single one will be a separate instance of this class. And they all inherit like the wag method and the bark method and all of that. So Fabulous. How about a class, Sydney? What is a class?
A blueprint or template that describes the behavior and state of the type of object it supports. So, template, you are physically like getting a copy of whatever types, personality, looks, things, behaviors from this particular class, and you're going to be giving it to the object that that class is supporting.
Absolutely. And I like to think of classes as kind of like a rubber stamp. And every time you want a new object or a new instance of that class, you just stamp that rubber stamp. So that's how I've always thought about it. A blueprint is, again, it's great because it's like it tells you how to build a house. If you're building, you know, a series of houses in a development and they all have the same structure, there you go.
That would be really boring. I would really hate my house to be cookie cutter like that, but I understand the analogy. That makes sense.
You're in for a treat when you come to Atlanta.
Oh, fuck. Great. Fuck. Okay. Let's kind of go a little bit deeper inside of different classes and talk about methods. And so I tell this to my students all the time, like kind of going into the JavaScript realm, that, you know, you have these functions that are, you're going to be compiling and getting a result. And so methods are going to be the same thing. It's just that they're in classes. So that's, from what I've always understood, that's the stark difference between functions and methods. For Java, methods are going to be a behavior. They are a class that can contain, classes can contain many methods. So many things that you're wanting to execute when it comes to the personality, when it comes to the different things that you actually want this particular class to do. Methods are where logic is written, the data is manipulated, and again, actions are executed. So if you're wanting the dog to
where
bark,
the magic happens.
Yeah, that's where you're going to be putting in a method bark. So you might be able to compile to the console that, okay, we're going to make a string that says the dog can bark and go from there.
And then we've also got these things called instance variables. And we kind of touched on these a little bit earlier, but essentially each object has its own unique set of instance variables. So if I have a dog and Sydney has a dog and Kelly has a dog, each of these are going to be 3 separate instances of the dog class. And each one of them has different properties. So an object state is created by the values assigned to these instance variables.
Yeah.
So that's kind of what that is. Let's talk a little bit about the basic syntax. So there are some things that are just kind of required or not required. Yeah, I guess kind of like they're, I don't even know the English words anymore, but they are things that you should do if you're writing Java. Okay, so case sensitivity is very important. So if you've got camel case, my dog is not going to be the same as title case, my dog. So like they're 2 separate things. So make sure that you're aware of that. It could lead to some bugs. All class names should be in uppercase. So that means that every new word is capitalized. All method names should begin with a lowercase letter. I think this is what we call camel case.
Yep.
The program file name should match the class name exactly, which I didn't know. And I said this earlier, but public static void main, and in your parentheses, you got string args followed by the array brackets. This is the Java program processing starts from this main method. This is a mandatory part of every Java program.
I didn't know that. I didn't either. So that's great. So cool. That's good kind of the basic syntax. If we missed anything, y'all be sure to let us know on Twitter because I'm still a Java noob. But let's talk about something that's always confused the living hell out of me, and that is inheritance. And we can't, I'm going to go through this and then I will give you an analogy to help clarify this in your minds. Yeah, sure.
So we've talked about classes. Classes can also be derived from classes. So if you need to create a new class, but there's already a class that contains some of the code that you require, it's actually possible to derive your new class from the existing class. This allows you to reuse the fields and methods of the existing class without having to rewrite the code in a new class. And I think this is awesome. So you might have heard of superclass and subclass. The existing class is called a superclass and the derived class will be the subclass. And we can use this keyword extends. So if you see extends, so like class dog extends animal. Let's say we've got an animal class. It has a type, it has a name, and it has an age. And our dog class has everything that's inside the animal class. let's say our animal class also has a method. It's make sound. Okay. So our dog class has all of those things, but it also has a wagtail class because not all animals have tails. They don't wag it, whatever. So we've got class dog extends animal. And if a class is inheriting the properties of another class, the subclass automatically acquires the default constructor of this superclass. But if you want to call a parameterized constructor of the superclass, you have to use the super keyword. So you might see that in the constructor of a subclass is the super keyword. That always confused me.
That always confused me too.
But yeah, that's how you would do. Like if you have like in our dog class, let's say we've got some extra like fields that we need. Maybe we could do like I don't know. Like Instagram handle. Let's say all of our dogs are famous. Okay.
Sure.
I don't know. I'm making this up. So inside our dog constructor, we've got this Instagram handle, but we also need to like pass all the other arguments to our super class. That's where you would use the super method to do that.
Okay. Yeah, that makes sense.
That tripped me up a lot when I was learning. So I'm happy I figured it out now when I don't actually program in this language.
Isn't that great? Like you suddenly just don't work with it anymore and it all starts falling into place.
Clicks.
Yeah, when you're not like traumatized.
I mean, but here's a really great example, though, of the more experience you have learning a particular language, it applies to other things you learn as well when it's a completely different language as well. Like a lot of concepts will still somehow carry over or mirror, which is why once you establish that baseline, it's a little bit easier at times to pick up a new language or a new library or a new framework because at some point there are replications from one to the next.
That makes a lot of sense. I think that's why I kind of understand going into classes with quote unquote object-oriented JavaScript a little bit more because of my trauma. So
you shouldn't be laughing about your trauma.
Right? I've had my therapy with it, but anyways, let's start kind of going into interfaces, which is I have never been able to completely understand and grasp this, but we're going to try. It is a contract between objects on how to communicate with one another. So for interfaces, this defines the method as what a subclass should actually be using. So hopefully that makes a little bit more sense now that I've had to try a third time.
None of it makes sense to me.
No, so. I don't understand it. But let's read from a tutorial, which I'll link in the show.
That makes sense.
Okay. So it says, an interface in Java is a blueprint of a class. It has static constants and abstract methods. The interface is a mechanism to achieve abstraction. There can only be abstract methods in the interface, not method body, and it is used to achieve abstraction, which we already said. In other words, you can say that interfaces have an abstract method that's literally just repeating itself. So fabulous. Okay. If you want to know what an interface is, don't ask us.
If you want to know, there's a really great resource that I use to learn things called Google.
Cool. We'll link it in the show notes.
Cool.
Fabulous. So we've touched on classes, but there are just a couple other things that I want to mention about classes. There are a few different variable types. Sydney, do you want to tell us about those 3 different variable types that you can have in a class?
Yeah, sure. So again, we're talking about classes, contains any of the following variable types. So we have local variables. These are defined inside of methods. Also constructors, or blocks, and will be destroyed when the method has completed. So they're not going to be kept in memory forever. I think that depending on like the actual structure of privacy of the variables, that will either be stored or will be deleted depending on whether or not the job is done. So local variables, it's going to be used and then it's gone. Instance variables are variables within a class, but outside any method, they can be initialized when the class is instantiated and then can be accessed from the inside of any method, any constructor, or any block that is within that class. And then we have class variables. So we have class variables that are declared within, of course, the class. They can be declared outside of any method with the static keyword. I didn't connect that until just now. That makes a lot more sense.
Yeah, that makes more sense now.
And then
I think some of these keywords are really confusing, like static and private. Like I never fully I never learned them. Which is stupid because I was
Like-
programming in Java and didn't know what any of these things meant. I was just like grasping at straws. So no wonder I hated it.
Right. It's like public. I think there's static. I think there's private. There's another one.
Protected. Like what the hell? Did
protected.
you build a moat around it?
Yes.
Yes.
Pretty much.
With sharks.
Something like that.
These things are called access modifiers, and obviously they tell you how you can access these different things. I don't fully understand the difference.
Default, I'm not 100% sure. Public, you can use pretty much anywhere in the class. Protected, you can only use in some instances, like within that class. I don't think that you can use it outside of it. And there's certain restrictions that you can do like inside of whatever that class that you're doing with it. Private, I know for a fact that you can't use it like anywhere else in your code for like wherever it is. It needs to stay in that specific area. And then final, abstract, and strict. I know that they have their non-access modifiers. I'm forgetting off the top of my head like what they're supposed to be doing. So we're gonna look that up.
There's I'll link in the show notes. There's a page on Oracle, who now owns Java, but they have a couple of different tables that explain the access levels of public, protected, no modifier, and private, where you can access those things, whether it's in the class, the package, the subclass, and the world. There's also a visibility table as well.
Ooh, yeah.
So if you're interested in learning more about access modifiers, just go check that out in the show notes.
Yeah. We're going on to constructors, right?
Indeed, we are.
So every class has a constructor, right? Yeah, every class has a constructor. And if you're not explicitly declaring a constructor, the Java compiler builds a default constructor for that class. So that had always confused me. So there's like an invisible constructor if you're not planning on like using that physical constructor to make or execute like any properties inside of a method. So I think that's interesting. I think that that's great that Java assumes for you. But do I ever remember that there are different like types of constructors that you might need when it comes to the invisible one, as well as like whatever one you type? That's a little bit going over my head. But yes, you can have different types of constructors, and Java likes to compile a default one that is invisible to the human eye.
Yeah, I don't think I've ever created a class without a constructor, and I didn't know they would automatically build you one. So that's kind of cool. There are a few steps when actually creating an object. So declaration is when it's essentially a variable declaration with a variable name and an object type.
Mm-hmm.
Instantiation uses the new keyword, which is a protected keyword in Java. It's used to create the object. Then you've got initialization, where you've got the new keyword followed by a call to the constructor, and this initializes your new object. So in the dog example would be like new dog, and it would be like you pass in the string for name, and you pass in the number or the int for age, and etc. So that's kind of the difference between declaration, instantiation, and initialization.
And what else is there? Enums, I guess we can talk about next. Have you had any experience at all doing anything with enums? Is it enumerators that's short for?
I don't know. I don't know what it's short for, but I use enums with TypeScript.
Mm-hmm.
Same exact concept, but it was introduced in Java 5.0, and I think, what did we say we're on Java what now? Like
16
or something?
16, yeah.
So it was quite a while ago, and essentially they restrict a variable to have one of a set of predefined values. These are super duper useful.
Mm-hmm.
So for example, let's say you've got an enum for shirt colors. You have an online store, because e-commerce is a thing that people do with their lives, like Kelly knows. Let's say you've got an enum for shirt colors. We only sell blue, red, and yellow.
Mm-hmm.
You can create enum shirt colors, and then in curly brackets, it's just blue, red, and yellow. And so anytime a shirt needs to have a color, when you're instantiating this object or initializing it, you can pass in one of these three shirt colors, and it'll provide those values for you. And it's nice. I don't know if Java has auto completion. I would presume that your IDE would take care of that. But it's really, really useful. I absolutely love enums.
And these don't change. You would not normally change these enums in any way, form, or fashion.
No, like I don't think you mutate them at all. I think they're like set.
Yeah.
Yeah.
That's another thing.
Cool.
Let's go into basic data types. We have...
Since we started with the most confusing one.
Yeah, basically. So we've told you guys that Java is a strongly typed language. And so you're going to need to make sure that you are expressing whatever the type of data, variables, whatever you're trying to execute kind of going forward. And so there are 8 primitive data types that you would normally use going forward. One would be byte. What's that one? It's
just 8 bits, right?
Yeah, it is 8 bits.
But I don't understand what you would use it for necessarily.
Very, very, very fractional small numbers, like really minuscule. And you wouldn't even use it for that, I don't think. I think that typically you would use int, the integer.
Yeah, y'all are going to have to look up the specific use cases or definitions of these. We're just going to tell you what they are so you know that they exist.
There is byte, there's short, there's int, integer, there is long, you would use that for longer numbers. There's float, there's double, of course there's Boolean, and then there's char, however you want to say it, character, you know?
Yeah, I say char even though I know that it's pronounced character in long form. But, you know. Yeah, so why the hell do they have so many primitive types for like numbers? I don't know. I don't care. I don't use Java. I'm sorry. I'm being facetious. So the difference between, and this is actually a really common interview question that I got when I was interviewing for backend jobs, was like, what's the difference between a primitive and a reference type? Like primitives are going to be like literals. So like It is a string, it is a number, it is a true or false value. Reference data types, which we're about to talk about, reference objects essentially. And they are created using defined constructors of the classes. They're used to access objects. So they're declared to be of a specific type that cannot be changed. So employee or dog. And class objects and array variables fall under reference types. And yeah, I guess the default value of any reference variable is null. So that's kind of the difference, is one is a reference and one is a literal.
The actual like thing, yeah.
Yeah.
What about overriding? What's going on with that?
Overriding and overloading. That was another question that I would get. No, it's actually quite easy to explain, but overriding, what's the difference between overriding and overloading? That's a question that you would get a lot when interviewing back in the day. I don't know if you still get this, but essentially, if a class inherits a method from a superclass, so let's say our dog class also has a make sound class. So it doesn't have a bark class. It has, again, a make sound class. You can override this method from the superclass, from the animal class. And what you would do then in your dog class, you would actually define the same method with the same name. So it would be make sound, and anything inside there is now overriding the superclass's method.
Okay.
So a benefit of overriding this is the ability to define behavior specific to the subclass type. So that's what overriding is essentially. Again, you do this by declaring a method with the same name as the superclass. And that's kind of how you would override something.
Okay, then. We also want to make sure that everybody understands that, this is an object-oriented programming language. So you're going to want to at least know about the 4 fundamental object-oriented programming concepts going forward, right? And so we've already discussed inheritance. So that's one. You're going to be potentially looking at subclasses, superclasses. You are also going to be talking about the concept of polymorphism, which is the ability of an object to take on many types of forms. And so the most common usage of polymorphism in object-oriented programming is when a parent class actually a reference of the parent class is used to refer to a child's class object. So we have here, for an example, public, interface, and the vegetarian. And we also have what is a public class animal and, public class deer. We're going to be extending animal, and then we're going to also be implementing vegetarian also in that whole class. So I love that we have to have all those keywords, extends and implements, to make sure that we're moving in the different properties that we need from animal as well as vegetarian to even do anything with deer.
Indeed. Another fundamental OOP concept is abstraction. So this is where you're actually dealing with ideas rather than events. So for example, if you're sending an email, it's the details like what actually happens when you send this email. So like the protocol your email server uses, these are hidden from the users. And so abstraction in Java is achieved using abstract classes and interfaces.
Okay.
That one still, again, confuses me because I'm not a Java expert. The other one that I thought I knew until I started writing this outline, and I was like, oh, I didn't know what this was at all. Encapsulation. One of my favorite words I use in my day-to-day lexicon. So encapsulation is wrapping variables and methods within a single unit. So you declare these variables as private, and then you provide the public setter and getter methods to modify and view these variable values. So if we have an example, let's say we've got private string name, private string ID number, and private int age. So we're taking in a name, an ID, and an age. Instead of exposing these to, all the instances, they're private. And so we have to have these get age, get name, get ID number, as well as set age that takes, the new age and sets it, set name, set ID num. And that way you're not exactly exposing these inner variables. You're providing these methods to mutate them, essentially. And this is much more secure, if I'm not mistaken.
Yes, very much so. So you have those get age, that is the getter. That's what you're wanting to make sure that you get back, essentially. And then you have, of course, the setters where you'll be able to actually physically set them yourselves. Yeah.
Indeed. So that was a very
robust,
shallow deep dive into Java. But these are just like the whole point of this was just to give you a brief overview of a lot of the terminology that you're going to be hearing about this language. It's really hard to teach a language over a podcast. So we're going to link a couple resources in the show notes. Oracle has a ton of documents, resources. They might not be the sexiest to read, but they exist. YouTube is probably one of the best places to go because it's free and there are some incredible tutorials on there. So be sure to check those out if you're interested in learning more about Java.
We also want to make sure that we are linking to Angie Jones's course on Test Automation University. I think that would also be very helpful for people because she explains a lot of the Java processes very well for my tiny brain. So I really love having to work with her and her resources. So make sure you check her out on Twitter. Make sure you check her out on Test Automation University. She is the Java queen.
This is free, isn't it?
Yes, it is free.
Are you joking me?
No.
Okay, this is a gold mine. So forget everything I said. Just go watch Test Automation University course by Angie Jones. We're linking that in the show notes. And it's free. Are you kidding me? Okay.
Make a new profile. Yeah, and that's it. Yep.
Absolutely. And make sure that you tag Angie and let her know that you watched it.
Yes, very much.
But let's quickly transition into shout outs. I'm going to let Kelly go first really fast.
Yes. My shout out is to the two of you because you carried this episode and I just existed. I found an analogy on the internet and I also recommended Google. So that was my contribution to this episode. So thank you both.
You are welcome. Have a nice day. So,
oh boy.
Okay. This is why we shouldn't record late in the evening my time. But in any case, Susie, what's your shout out for this week?
My shout out is to Josie, Jocelyn Harper, let me say, and Angie Jones, because when they hear this, they will kill us. They will be like, y'all bitches need to figure your shit out. Because we've ratted on. We've ratted on Java so much. And Jocelyn Harper from the Get Cute podcast, she is very much so. She's a great teacher. She is really good at kind of breaking down the concepts of what you're doing in Java. And so she has a couple of episodes on where you learn with her different analogies when it comes to basic Java concepts. So make sure you check the Get Cute podcast. Also make sure that you check out Angie Jones for her Test Automation University course and go from there. So I love you guys. We're so sorry. Please don't kill us.
We should have had them on instead of us to explain this. But to be fair, look, hey, we did criticize Java. However, we did give our reasoning behind it. And I think it's a valid reason. None of us said it's not a great language. It is a great language. It's just freaking hard.
I think it's great. That was a lot for my tiny brain to handle on top of other stuff. So I've made my peace with it. I've I've gone to therapy about it. So we're learning as we go along. But Emma, what is your shout out?
My shout out is to my first manager who switched me to front-end development, where I fell in love with programming and finally realized what the I was doing with my life. So that's great.
So glad.
Also, fun fact, my first manager was actually my dad's manager for a long time at IBM. She's the reason I moved to Texas.
Oh, that's awesome.
So, fun fact.
That's so cool.
But yeah, if you didn't hate this episode, tweet about it. Each week we select a tweeter to win stuff, and this week we're giving away the O'Reilly book, Learning Java. So be sure to tweet how much you didn't hate this episode. We post new podcasts every Monday, so make sure that you're subscribed to be notified, and make sure to leave us a review only if it's good. Thank you, and we hope that you have a great day.
Thank you. See you soon.